Hello everyone, welcome to my online training. This is for beginners and those who have little or no knowledge about how the solar power system is being connected, the various components of a solar power system. Basically, a solar power system is made up of the solar panel, the charge controller, the battery bank, and the inverter. Then we have other components like the surge protective devices, overcurrent protective devices, the cables, fuse, and other components that are installed to make the solar system to perform efficiently. We also have a BMS, battery management system. Now, the solar panel is the generator. Once it is exposed to the sun, starts generating electricity in form of DC. As you can see here, the red stands for the positive cable, while the black here stands for the negative cable. So the energy that comes from the solar panel is direct current. As you can see here, is DC. It's direct current. It flows to the battery bank. But in between the battery bank and the solar panel, we have the charge controller. The charge controller here is for charging of the battery, to safely charge the battery and also safely discharge the battery. So the work of the function of the charge controller is to control the charging and discharging of the battery if you're using a DC load. You connect the load to the controller, it will also control the discharging, because once you connect the load to this controller, it will start discharging the battery. So the essence of the charge controller is to safely charge the battery and to also safely discharge the battery. Now, for the solar panels, we have the monocrystalline solar panel and the polycrystalline solar panel. These are the mostly used, common used solar panels in the market. Then for the charge controller, we have MPPT charge controller and the PWM charge controller. MPPT stands for pulse width MPPT stands for maximum power point tracking, while the PWM stands for pulse width modulation. The MPPT charge controller is more rugged than the PWM charge controller, and it is also more expensive than the PWM charge controller. Now, if you have a solar system that the voltage, the solar system with a very high voltage, that is the voltage that is coming from the solar panels to the battery bank is high, it is advisable for you to use the MPPT charge controller because it can handle high voltages. But for PWM, they are always designed for 12 volt, 24, 48 volt system. So they don't have that capability or capacity to accept high input PV input range. But the MPPT charge controller have that capability to accept a high voltage from the solar panels. But you also need to always look at the specifications of the charge controller. It is always written on the specification sheet of the charge controller. Then the battery bank here is a storage device. It is like a reservoir, a storage tank, that you store the energy that is being harnessed by the solar panels during the day, because the sun is only available during the day. So after the solar panels, generate the energy during the day, the energy needs to be stored in this reservoir so that in the night, when the sun is not available, you can make use of the energy. So that is why you have the battery bank. The essence of the battery bank is to store the energy that has been harnessed by the solar panels during the day, so that you can make use of the energy anytime you need it. Just like your storage tank where you pump water and store, then later in the day you can make use of that water even when the pumping machine is not there. Then if you look here, you can see that we can power a DC load from the charge controller. You can see it here, DC load. You can connect a load to the charge controller because there's a terminal here, an input side where you can connect your DC load. But the DC load, the input voltage or the voltage of that load must match with the battery bank voltage. So if it is a 12-volt battery bank, it means you need to use a 12-volt load. If it is a 24-volt battery bank, you can use a 24-volt load. Now, at times you may have a 24-volt battery bank. Then there are some loads. They will write there that you can use 12 volts and up to 24 volts. So you can use those loads in both 24 and 12 volts battery bank. But if you have a 48 volts battery bank and the requirements of that load is below, that's the voltage input of that load is below 48 volts, it means if you connect it to the 48 volt battery bank, it can destroy or burn that load. So you can as well connect your DC load to the charge controller. You have many DC loads, bulbs, DC fan, DC freezer, DC air conditioners. Then the next one is the inverter. The function of the inverter is to convert, as you can see, DC here. So we need loads. We need to power our AC load, as you can see here. But you cannot power this AC load directly from the battery. If you connect an AC load, that is alternating current load, to this battery that is DC, that load will not work because it is not an AC load. So we need something that will be able to convert the energy that is stored here to AC so that we can use our conventional AC appliances. So that is why we have the inverter. So the function of the inverter is to convert DC to AC. That is direct current to alternating current so that we can power our AC loads. So other components, like I told you, are the breakers. We're installing protective devices here. We're installing a breaker here. Between the solar panel and the charge controller, we need a breaker. We also need a fuse. We need surge arrestors. You can also install your DC disconnect. That is to disconnect the solar panels from the charge controller. Or between the charge controller and the battery bank, you also need a protection. So you need to install a breaker there also. Then between the battery and the inverter, you also need, there are, most of the modern inverters today, they have breakers, inbuilt DC breakers. So you need an external breaker. The inverter already have, a DC. And between the inverter and the AC load, an AC breaker or AC protective devices. Then here also you need a breaker. Then you also need to know how to properly size these cables. These are all cables, interconnecting cables. They are used to link all these components together. So you need to know how to properly size these cables. So if you have not subscribed to my channel, please do subscribe so that in my next videos or subsequent videos, I will upload, show you how to properly size these cables, properly size, your breakers, either DC or AC, such protective devices, and also show you how to do the installation either on the roof or on the pole or on the ground. So if you have not subscribed, please do well to subscribe so that you can follow my recent uploads. Thank you very much for joining me.